Okay, there's some question on stability from your friends. All right, this referring to question 3. All right, why does the center of gravity lower from the midpoint of the cup? How does the bottom of the cup becoming denser than the top leads to the lowering of the CG? Okay, I'm going to try to explain this by using simple diagrams. All right, so if I have a block here, the CG is just, I draw two diagonal, it must be here, right? So this is where the weight X and this is the CG, center of gravity, right? If I attach this block to a new block, exactly the same thing, right? The CG of the second block is here, right? CG is CG2 and CG1, right? So the weight X through here, right? So, but if I look at this thing as a system, as in these two blocks are attached together, right? I will say that if for this to balance, I have to place my pivot here, which means that the new CG of this system actually lies vertically above the pivot, which is here, right? This is the new CG. The new CG of both blocks, right? The other way to look at it is, if I'll just draw these two things as one block, then the CG must be here, which is exactly the same thing as this one, right? Exactly the same position as this one, okay? So that's why the pivot should be here, right? So can you understand what is the meaning of the center of gravity of the body now? It's the position where the weight seems to act. And if I put the pivot vertically below the center of gravity, then this object should not rotate, right? So if I were to now think about this a bit differently, so let's say this one, the same thing, but instead of attaching one block here, I attach another block behind. Alright, so this one is like 2x the mass of this one. So it's 1x the mass, right? You know that the CG of both bodies is still here and here. But do you think the new CG is going to be at the center in this case? Right, cannot be, right? If I put a pivot here, right, I know that this thing is going to rotate clockwise. Because this one is 2W, and this one is W, and these two are the same distance. Right, you can straight away see that the moment due to this one is higher than this one, right? So clearly this thing cannot balance with the pivot at the center. So where must the pivot move? Clearly I must shift somewhere here, right? So I must shift somewhere here such that exactly below the pivot, exactly below the center of gravity, where I place my pivot, right? Let's say if I know that the new CG is here, right? I know that it must be within this one because I need to shorten this one and lengthen this one, right? So that I can balance. So I know the pivot must shift right. So if I shift right somehow to this location, such that it's vertically below the center of gravity. So let's say I know the center of gravity is here. Actually, I don't know. I just shift the pivot until it doesn't rotate. Right? Then when it doesn't rotate, I know that, oh, this thing must sit directly below my center of gravity. Because if the new center of gravity function acts like that, which is 3W, right? The new center of gravity acts like that, it runs through the pivot, then this thing balance, right? Then this pivot location actually tells me my new center of gravity. And why does it shift closer to the heavier object? Because of what I just mentioned. If I put at the center, in this case, the heavier object will grant you a greater moment, right? So to balance the greater moment, the pivot must shift more to the heavier object, and therefore that implies that my center of gravity must be closer to the more massive substance. Okay, so you get what I'm trying to say so far, right? So if I look at this case of the cup, right? So this is an example of the cup. The cup itself, right? Mainly the center of gravity is here, but this is a light cup, right? So this part, the center of gravity is low mass. So if I call this, for example, M, maybe the base, right? Maybe they make of lead or something, right? The center of gravity maybe is somewhere here. It's a bit harder to find, but roughly it's here, right? This is the center of gravity of the bottom part. But this high mass, maybe this is like 50 M. Can you understand why the center of gravity, the new center of gravity of this body, should be actually very close to this one? Because this is so high. For me to put a pivot here, okay, you need to rotate the cup here. For me to put a pivot here such that the center of gravity falls such that it cuts through the pivot, the weight at the center of gravity falls such that it cuts through the pivot. Okay, I actually need this perpendicular distance to be very small because my weight will function like that. Okay, you have to bend the cup a bit, but this weight is a lot bigger than this weight is 50 times. Right, this weight is 50 times this one. So my perpendicular distance here need to be a lot shorter than this one. Alright, so that's why when there's a more massive attachment, right, the center of gravity tends to trend towards the more massive thing. Right, I'll answer the second part of the question in another video.